Okay, so you know, this is the option for radio frequency. Okay, normally we talking in the summer. However, I believe for the budget problem, so that's why this summer will be closed. And this is really helping you to get a knowledge, okay, about electronics. So first thing for tech you, if you already done for digital lab 14, that's the last one, okay? Then basically you don't have to do anything else. However, what I thinking, we get 2 more weeks to go for the spring 2025. And I really want you to get into the class to do. We get 2 circuit boards for AC, AC1, and AC2. And I want you to do it. Okay? That's for your knowledge. Okay, so any question or anything else, let me know. Okay. If it's not, then we'll be stuck, okay, with the IF. Okay. This will be electromagnetic spectrum, okay, from 30 hertz up to 300 gigahertz, okay? They already telling you, okay, from what frequency to what frequency, okay, for anything else like LF, MF, SF, VSF, and so forth, okay? The thing is, if you want to doing anything on the air, then you have to get a permission. Otherwise, you can get into the problem. Okay? The thing is radio have to be transmitted from what frequency to what frequency. Okay? And so on. Nobody can do whatever they want. Okay? In here, the high frequency 3 mega to 30 megahertz very high, ultra high, super high, and extremely high frequency. Okay, so this also telling you what frequency they're doing what. Okay, now this one you already know. However, basically, okay, have to be basic definition. You have to know what is the cycle, what is the frequency, period, or wavelength, okay? And you must be reading that to make sure the definition for each one. In here, okay, how cascading filter section narrow the bandwidth and improve selectivity. You see that a different filter, you get a different signal. This for 3 section to 1 filter. Okay? And you understand, we already get through the filter. Okay? Active filter. And passive filter, however, they're working identical. Passive filter offer on summer. And you already get through the active filter. The difference will be active filter, they're using the op amp. They need the power supply. Passive filter, they're using RCL only. Don't need the filter power supply. Okay? They working the same thing. And this one also they given you the picture of the different engineer design the filter. That will be part cell butterford elliptical geometry. Okay? And when you're looking into the picture, you try to recognize which one will be good or not good. First thing I'm talking about ripple here. What is it?
It's
What is a ripple?
Noise?
sound.
They will be the noise. What is the noise?
Unwanted signal.
Perfect unwanted signal. That means the signal you don't want it, and they be there. That's what they call a noise. When we're working for the government, we have to design electronic for them. One of the requirements will be ripple. The noise have to be like 0.01 millivolt, for example. Okay? So now if you're looking into 1, 2, 3, 4 filter here, 1, 2, 3, 4. Which one you think the good one?
I like the Butterworth.
Okay, you say the Butterworth. That means this guy. Okay. Who else?
Elliptical.
You say elliptical. Now, what we want?
Oh, wait, let me think. Bessel.
What?
Maybe Bessel.
Best sell? Okay, so how do we know? Filter good. Filter good will be very, very narrow for band path. So this one is not good, but the fourth. Why? The wider, okay, for the band path. I can tell you this one elliptical, not good.
Right,
The thing is
right.
too much noise. Okay,
Mm,
so on this one, the best will be best sell. First thing, they have a no noise, right?
mm-hmm.
And also they very close, okay, to the band path here. Better than cavity, okay, or elliptical, okay,
Mm-hmm.
or butterfly. That is to recognize which filter will be good.
Mm-hmm.
And another picture here telling you, okay, this is the sideway, square way, sorry. So basically, square wave basically combined by the side wave. Okay? More side wave, they will be make up the square wave. And here they already telling you, okay, the fundamental side wave for 1 kilohertz. Okay? And the next one, they will be a third harmonic, okay, and keep going. That make it up the square wave. Okay? So square wave basically make it up by sine wave. And they're going by the harmonic using odd harmonic only. First harmonic, first one, basically fundamental. First harmonic will be 3K. If we're using fundamental, 1K. And fifth harmonic and so on. They're using only odd harmonic. Okay, now complex waveform. A complex waveform is any signal that's not a sine wave. Okay? And you can get a square wave, triangle wave, sawtooth wave, human voice, music, or digital data. Okay? Any periodic signal that is not a real sine wave can be considered to be built out of the following component. a DC component, however, which can be zero. Fundamental sine wave that has a frequency exactly the same as the frequency of the signal. Infinite number of harmonic is a frequency that is exactly multiple of the fundamental frequency. In perfect square wave, there are infinity number of frequency present. We only need to analyze up to 13 harmonic. Okay, they can go forever. However, for working, they will only go up to a 13 harmonic. Okay, to get a descent reproduction of the square wave. Okay, now you can see they will be display a square wave here. That's what you will be see in oscilloscope. Okay, they get a V peak to peak 1 volt minus 1 volt. Okay, for 1 kilohertz. Another one will be same thing. However, they will be displayed on spectrum analyzer. This equipment using for the lab in RF radio frequency. And you can see this is the first one. Okay, fundamental. Okay, fundamental. Okay, or first harmonic. And they go to a next one. Third harmonic. That means 1K, then 3K, and so on, 5K. Keep going. This is the frequency domain. That means the signal varies with the frequency. Okay? And this is the time domain. Signal varies with the time. And you understand, through that equipment, one will be oscilloscope for the time domain. And another one, spectrum analyzer, that for frequency domain. You can see the big difference on price. Oscilloscope you can buy for $1,000 to $2,000. However, spectrum analyzer we get in the lab that cost $24,000. Got a big difference. Okay. So before they get a private school teaching electronics, but they still don't have money to buy spectrum analyzer. Cost too much. Okay, this again, they just showed you signal square wave on oscilloscope. And that on oscilloscope, and it will be displayed on spectrum analyzer. Okay, now we see. You get a square wave oscillator. You know, an oscillator, right? You can go to electronics store, you can buy oscillator. If you say, okay, I want 1 kilohertz oscillator, square wave, they given you the IC. When you get the power, they going out. Square wave, 1 kilohertz. You cannot change to different frequency. Okay. And you can go up, okay, the frequency. And if they go to a band pass filter, how did band pass filter working? Who knows?
It passes frequencies in specific range and blocks all the other ones.
Right. They're telling you, no matter what frequency coming in, coming out must be 3 kilohertz. Okay. Other frequency, they're not allowed to coming out. And this will be displayed on the spectrum analyzer. Okay. Only third harmonic present. You see that? Only what? The thing is output of the band pass filter. We already learned band pass filter. They pass any signal with the bandwidth from F1 to F2 or F low to F high. Okay, electronic communication is everywhere. What the TV, okay, broadcast or listen to the radio or use a telephone, use remote control and more. Okay, electronic system. A system can be defined a group of components that work together to complete a job or a task. A subsystem is just a part of a system. It helps to complete a task. A subsystem is often shown in the block diagram. Okay, now this one, like you can see the trend meter, like you're talking into your phone. Okay, so you can get a microphone in here. They converting your voice into electrical, okay, into the signal. And they get to get the voltage amplified. The thing is, our voice, the signal very weak, cannot transmit it. So that's why they need the power amplifier. And then they can go into the antenna, transmit it over the air. That's for transmitter. The next picture we're talking about receiver. Like this is your phone, or this is radio. You get an antenna. Signal from antenna go into your radio. And they need the power amplifier. And they can go into speaker. That's a picture very simple, okay? Telling you for signal transmitted over the air, okay? Or receiver over the air, either for your radio or your phone. They working the same, okay? A microphone is a type of transducer. It's converting the pressure variation in a sound wave into electrical wave. Okay? A transducer is any device that converting one form of energy into another. The transmitting antenna converter, the amplify information signal into a new form of energy capable of traveling through the space. Okay, this new energy is called electromagnetic energy or radio wave. Okay, electromagnetic energy consists of two fields, a voltage or electric field and a magnetic field. Okay, it travels through the space at the speed of light. Okay, which about 3 times 10 power of 8 meter per second. That's how the signal transmitted over the air. Transmitting antenna requirement. So basically, if you want to design antenna, then that's why you need to go. Okay? Radio transmitting antenna need to be at least 1/4 or wavelength long. Audio frequency are those we can hear. They are from 20 Hz to 20,000 Hz. And audio frequency, okay, that is in the middle of our hearing range, 1,000 Hz or 1. Lambda equal, okay, antenna need only be 1/4 of this distance or 75 kilometers. Increase frequency always decrease the wavelength. Decreasing frequency always increase wavelength. Let's try changing from 1 kHz to 10 kHz. So lambda equals 30 kilometers. And the length of antenna will be 7.5 kilometers. If frequency f equals 150 megahertz, lambda equals 2, antenna will be 0.5 meter. Modulation. 100 megahertz signal may transmit just fine, but there are one more problem. We cannot hear 150 megahertz. It is too high in frequency. This is a solution. It's called, okay, modulation. When we modulate the wave, we replace a low frequency information signal onto it. The low frequency signal is just a long for the right. It is effect carrier on top of high frequency signal. The high frequency signal is therefore called carrier signal. Basically, you understand your voice. The frequency very low. and that low frequency cannot transmit it. Okay, so that's why they want the high frequency. You can see the signal 150 megahertz antenna is only 0.5 meter. Okay, so the signal will be transmitted very high frequency. However, your voice at a low frequency. So that's what they need. They need a high frequency to carry your voice. Okay, that's what we call a carrier signal. This was just for you to read it. Okay, I'm not going to that example. They already get the solution. Okay, there are three ways we can impress information onto a carrier. First, we can voltage or power of the wave in the step with information. This is called amplitude modulation AF. Or we can alter the frequency of the wave with the information. That's what we call FM, and next will be PM phase. Okay, so that's why you can see you get a FM, you get a AM. Okay, practical radio system. Every radio transmitter is assigned to operate on specific carrier frequency. The job of the carrier oscillator is to generate this frequency. The purpose of an oscillator is to convert the DC from power supply into AC signal. The output of the carrier oscillator is a nearly clear sine wave. The modulator has a two inputs, the radio frequency sine wave from the carrier oscillator, the information signal. The output of modulator is a modulated carrier wave. That's just a basic definition for you. And in here, okay, this is basically just a check out. For example, what is the purpose of oscillator? Okay, and basically they say the job of carrier oscillator to convert the C from power supply into AC carrier frequency. Okay, the thing is, if you want to know, you have to buy a textbook on our app. Okay, that's what I get, that textbook. I go through that and I see whichever, okay, we can give it to you to understand. Okay. Okay, now you see the picture. This is the transmitter. This is the receiver. Okay, so the transmitter, you get your voice here. You have to get a voltage amplifier. Again, our voice very weak, cannot transmit it, cannot working with the electronic. So that's why they need the amplifier to make to a certain voltage can be working in electronic circuitry. Okay, and they go to what we call a modulator. Modulator, they get two signals. one coming out RF carrier oscillator. You can go into electronics to buy any oscillator you want. 1 kilohertz, 1 megahertz, 10 megahertz. Okay, so that two signal going to modulator. After modulator, they get a signal coming out for RF power amplifier. Then go to the antenna to transmit it over the air. That is the picture for transmitter. Second picture for receiver, your radio, your phone, whatever. Basically, the signal transmitted over the air. Okay, and this is the antenna. So the signal coming in antenna, and that goes to band pass filter. That means when you select the radio station, so they only allow frequency on that station will be coming in. Okay. Then they go to IF radio frequency amplifier. They go to detector, the modulator, and go to amplifier, power amplifier, and go to speaker. On the process for radio, TV, or cell phone, or phone, okay, they're working the same thing. Okay, making AM signal. This is the oscillator. You already see that oscillator right here. And this is your input, your voice. Both will be go into modulator amplifier. Now see what happened. The first stage in any transmitter is oscillator. The IF carrier wave contains no information until it is modulated. Okay. In order for amplitude to be changed, the voltage or power gain of a subsequent state must be changed. AM generator has a special amplifier with variable voltage gain called modulator. Okay, the amplifier with a constant gain is called a linear amplifier. The variable gain amplifier is a non-linear amplifier. Non-linear amplifier is always required to generate AF. Where is the information? In AM signal, the information is carried on top of RF carrier. The actual shape of carrier is altered by addition of the information during the process of modulation. The image line that make up this shape are called envelope. Okay, the envelope is a copy. Okay, or duplicate intelligent signal percentage of modulation AM In AM signal, percentage of modulation is a measure of how strongly the carrier wave being changed by the information. For radio, the higher percentage of modulation, the louder the signal will be in receiver loudspeaker. The variable gain amplifier is a nonlinear amplifier. Okay. A nonlinear amplifier is always required to generate AM signal. The maximum percentage of modulation 100%. 0% modulation means that no modulation is taking place. The transmitter is said to be dead, key, or unmodulated. AM modulation, okay, index is the same information as the percentage of modulation. It is given simple M and can have a value between 0% modulation and 1 or 100% modulation. Okay. When calculate the percentage of modulation AM signal, we are really calculate the modulation index. Remember, maximum modulation index is 1. That's 100%. A signal that is over 100% modulated is said to be over-modulated, which is illegal condition. Over-modulation distorts the ill information, can cause excessive bandwidth to be used by transmitter. Example, what percentage of modulation corresponds to a modulation index M of 0.5? Okay, and you see percentage modulation 100 times 0.5, you get 50%. Okay, AM modulation index can be defined by the formula M equals Vm over Vc. Vm is the information voltage, Vc is the carrier. Okay, to measure the modulation index on oscilloscope using the formula here. If you want to display the signal on the oscilloscope, okay, then you can see this signal. Basically, in this signal, try to recognize this is your voice right here. That's your voice. Okay, inside here, the signal, that's what we call a carrier. So basically, the carrier will carry your voice over the air. And that's just helping understand. Okay, if you get time, you can read that. Okay, now let's see example. Suppose that AM signal, the Vmax peak-to-peak value read from graticule on oscilloscope is 5.9 division, and V mean peak-to-peak 1.2. They want to know calculate the modulate index M. Okay. And the next one V carrier, next one V modulate, okay, and M. See, in here they try to, okay, and if you want to do it, and you have to go back the formula modulate index. I think modulate index in here. Vm over V carrier. Okay. You understand is your voice will be here. Carrier, that means the frequency inside. Okay. And they calculate VC, V max, peak to peak, plus V minimum, peak to peak, and divide by 2. Okay. And also, another example here. Suppose that AM signal on oscilloscope at the oscilloscope setting 1 volt per division. So now they calculate AM, VC, VM. And if you're looking in here, they can telling you from peak to peak, 1, 2, 3, 4, 5, 6 division. Okay. And basically, V carrier, okay, 6 plus 2 divide by 2, and so on. If you get the time, you can look into that. And now you can see 100% modulation. Okay. And this also over modulation. Okay. You can see the signal. Your voice right here on the top. Okay. And this is the carrier. So you see both. And you can see over modulation. That means this line is too long. Okay. The intelligent voltage is too large for the carrier. But the envelope is no longer an accurate copy of information. Second, excessive bandwidth that will interfere with adjacent. Okay. Frequency domain, AM. Okay. In this domain, it's easy to measure the bandwidth and the total power of AM. Okay. You get the signal here. Okay. Will be 100 kilohertz. The amplitude will be here. Okay. And now this will be 100K carrier modulated with 5K information. Your voice right here, 5K. Okay. And the carrier 100K. So they're telling you on the lower side you get 95K, higher side 105K. Okay. Frequency domain divide. Okay. The figure above show 100K sideways in frequency domain. How do we know this is a sideways? Since there is only one frequency present. 100K. The sine wave is the only pure waveform, and it contains only one frequency. Okay, what happened when this carrier signal is amplitude modulated? Okay, in the frequency domain, the rapid changing amplitude show up at new frequency called sideband. Okay, sideband are the new frequency generated during the process modulation. They are created by the non-linear distortion introduced by the modulator amplifier. All modulation create a sideband, whether it be AM, FM, or PM. Suppose that 100K carrier, okay, amplitude modulated by 10 volt, 5K information signal. The resulting frequency domain picture will look like, okay, what are the sideband? 5K information signal seem to have disappeared in the display. In the reality, the information energy 5K has been transformed into the sideband energy 95K and 105K, lower K and upper K. The sideband contain the information, okay, at upside band FC plus FM, lower C, FC minus FM. Okay, so basically on that one, we already did that. And basically you see what they said. Calculate the bandwidth and modulation index of the AM signal. So bandwidth will be F max minus FM, 105 minus 95, 10 kilohertz for bandwidth. So M, we already know formula Vm over Vc. Vc is 10 volt. Vm is 2 times upper sideband. Okay, equal 2 times V lower sideband equal 1. Okay. And this try to doing a calculation. Okay. For you. Okay. Let's see. Okay, basically it's still too long. So what I want to do, okay, I want to stop for today. However, if we get a time, we get another Zoom for your guys. Just a few students in here. If you don't know the first part, you cannot understand what next. Okay? That are really, really good for you guys to know. Okay, so this is the last part for today. They say for AM signal. So in this one, calculate the following. Information frequency FM. Okay. F carrier equal upper sideband minus FM. Okay. Then FM equal F upper sideband minus F carrier. That will be 3 kilohertz. Okay. You know, they given you that carrier frequency. Okay, upper frequency, lower frequency. So you take S10 minus S13 minus S10. That's why you get lower side. Okay. V upper side band. Okay. That means they're asking you what the voltage here. That's easy to recognize. They will be the same here. 5 volt. Bandwidth. Bandwidth equal F max minus F minimum. Okay. Equal F upper sideband minus F lower sideband. Okay. So basically, you can get upper sideband frequency, lower sideband. Okay. So you can get from here S10, S13 will be 3K, 3K. So the bandwidth will be 6K. Okay. Finally, calculate the M equal Vm over Vc. Q divide by V upside band. Okay. Divide lower side band. Q times 5 equal 10 volt. Okay. And M will be 50%. So this thing, basically, if you get the time, you can go through that, okay, and try to learn in order to understand. That's what I try to cover the book. I bought it very long time ago. Everything needed for engineering, okay, not a technician, okay. That helping a lot if you want to know about basically the radio frequency on your voice, your phone, the signal transmitted coming out your cell phone up to the air and go to the another cell phone for receiver. Okay, everything that cover in this lecture. Okay, so
And
do you have any
like ham radios too, right?
yeah.
So I have a question. This uh PDF that you've been showing us is different than the one that you uploaded to Tech One site, right?
Same thing.
Same thing?
Yeah, that handout will be same thing.
Okay, because it doesn't seem like this is the intro key one that you uploaded to their site. It seems longer.
Same thing. Nothing,
Same,
nothing,
same,
nothing different.
nothing different.
Mhm.
Um, I'll have to look at what because
Right. You have to read not one time, too many times.
yeah,
Other-
I printed it out. It
Yeah,
maybe
in order to understand.
something happened.
Okay. The
Mm.
thing is, when you get a job interview,
Oh,
then you also talk to them. You can learn, you already learn about, FM, the RF, radio frequency. how signal transmitted over the air. Even go to your phone, your radio. How come they come up to the radio? Or how come they can come into another cell phone? And then after this lecture here, you can understand everything. How that signal transmitted, how that signal go into your cell phone, or go into the radio and go speaker. Or same thing for TV. Okay? They have to be transmitted over the air. And you already see at the beginning here, they already telling you what frequency transmitted for what. Okay? So radio will be going from what frequency to what frequency. Okay? TV, same thing. Okay? They have to get a different frequency, each one for each different station. 90 FM, 95 FM, or whatever. Okay? So any more question? Anything else? No? Okay, if it's not, so I will try to see I can get another day for this Zoom. Okay?
Okay.
Help your guy to understand.
Okay, thank you.
The thing is, that is really long. Okay?
Yeah.
So we'll be talking to you on Tuesday. We'll see you guys on Tuesday, not Monday. Okay? So I wish you guys have a good weekend.
You too.
Okay?
You too. Thank you.
Mr. Fan.
Thank you so much, Mr. Fan.
Thank you, sir.
Yeah, no problem.
Have
Bye-bye.
a nice weekend.
Goodbye, sir.
Bye-bye.
Bye-bye.